Today we are going to learn about how to identify the tail of a hypothesis testing. In order to find out which tail test, you have to look at the symbol in alternative hypothesis. Okay, you know that alternative hypothesis can contain not equal sign, greater than sign and the less than sign. If you see a not equal sign in your alternative hypothesis, then it is a two-tailed test. If it is a greater than sign or the symbol, it is a right tail test. Otherwise, it is a left tail test. So, this is the only case where you meet two tail test and other two are one tail test. Okay, according to the type of the tail, we are going to find out the critical values. So, next we are going to learn how to find the Z or Z critical values with these different tails. Let's move into that part. Let's see how you can find the critical values. In order to find out the critical values, you need two things. You need to know the significance level, alpha, and the tail of the test, whether it is a two-tail test, right tail test or a left tail test. Okay, at the beginning, you should know the alpha, value of alpha. Consider a z distribution with significance level equals to 0.05 and think that our test is a left tail test. Okay, so consider this normal distribution graph. You know that from the middle is our mean, and then left to that mean, it is the left tail. Right to the mean, it is the right tail. Because our test tail is a left one, we should draw this 0.05 from left of the graph. Okay, see, I have colored here 0.05 area from the left. Now you know, you just need to go to the Z distribution table to find out this one because it is a left-tailed one. You know that directly you can find out the value from the Z table because the Z table supports to find out the area left to some Z-score. So here in this table, you can see that 0.05 is here, right? So the value, Z value for that one in this row, this column, that is Z equal minus 1.64. Okay. Next we are going to find out how to find the critical value for the same significance level like last time 0.05 but for a right tail test. Okay. If that is a right tail test, you have to color 0.05 from right to some Z value. Okay. You know that this is the right tail. So in that one, from starting from the right side, you should color 0.05 area and then should mark some Z value there. Okay. Now, because the Z table support us only the left area to find out the particular Z values, you have to reduce this one and get the left side area. Then 1 minus 0.05 which is going to be equal to 0.95. Now you should look at 0.95 in the table. Now you can see that 0.95 is somewhat closer to this one. Yeah, this is somewhat far away from 0.95. So this is also somewhat far away than this one. So the value for that one is 1.64. In addition to that one, you know, you can find out this using the symmetric property, right? So even if you color a area that is left to some Z value, which is going to be the area 0.05 over here, like last time we did for the left tail test, this is going to be minus 1.64. So since we colored the same area in the right side, now this Z should be 1.64, the positive value of this one because of the symmetric property in the normal distribution. Okay, whatever the way, whatever the convenient way you can use. Next we are going to find out how to find the critical values for significance level 0.05 for a two-tailed test. Important thing is this is a two-tailed test. So we should have two critical values. How to get the two critical values? We should take that significance level and divide it by 2. Then we can find out what are those particular C values. Okay. When you divide this 0.05 into 2, then it will give you 0.025. Now you know that how we mark that 0.025 is one from left to some value and the other one from right to some value. Okay. According to the symmetric property, you know that these magnitude of these two will be the same and sign will be different. This is the negative sign value and this is the positive sign value. Okay. Now 0.025. We have to find out 0.025. Now it is over here. You can see in this column, in this row and this column. So the particular C value for that one is minus 1.96. Here, in order to find out the Z2 value or C2 value, because of the symmetric property, you can say that Z2 value is 1.96. Okay, here we go with the question. Find Z critical value or values for a left tail test, for a right tail test and for a two tail test with significance level equals to 0.01. First one, we are going to find out the left tail test critical value with significance level 0.01. Now you know that because it is a left tailed one, it is very easy to find out. Go to the table directly and take the value. 0.01 is somewhat closer to this value and other two values are far away from 0.01. So minus 2.33 is the Z value. So this is the critical value for that one. It is easy. Again, I am reminding that if it is a left-tailed one, you should color 0.01 area from the left side to some Z value. Then that Z value is the critical value. Okay. Next for a right tail test. Okay. Right tail test. So because it is a right tail test, you should color 0.01 area from right to some Z value. Then that Z value is the particular critical value for this test. Because of the symmetric property, you can just say that this is 2.33 because you already found that in the previous one. But if you need to do that in another way, just like using 1 minus 0.01 is 0.99 in the table, so you will end up with the value 2.33. Whatever the way you can use, but make sure that it won't consume much time. That's the major thing you should consider. Next, we are going to find out critical values for a two-tailed test. Okay, because our significance level is 0.01 and we have a two-tailed test now, you should divide that by 2. Then you will end up with the value 0.005. So we can use directly 0.005 to find out in the table. According to that one, you can see this value is the most closest value to 0.005. So value for that one, the Z value for that area is minus 2.58. Then Z1 value is minus 2.58. Because of the symmetric property, you know that Z2 is 2.58. Just drop the minus and write down the magnitude. Then that is the Z2 value. Therefore, the critical values are minus 2.58 and 2.58. Okay, hope you understand. It's easy and practice well.